Thanks, everybody, for coming out to see this talk today. I'm going to talk about using Deck.gl for high-volume data visualizations with the Google Maps JavaScript API. Let me turn these slides on. Cool. All right. So to get started, my name is Alex. I am a developer advocate on the Geo team at Google. Specifically, I'm a developer advocate for the Google Maps platform, which crosses a huge variety of different features. Many of you are probably, of course, familiar with Google Maps, but as well as places data, different routing APIs, all kinds of good stuff. Who here has done work with the Maps platform before? Nice, OK. Just a few people. Interesting. So that is my Twitter handle on the bottom. You can feel free to reach out to me at any time if you have any questions about anything I covered today or about maps in general. Also, feel free to interrupt anytime during the talk and yell out a question if you have any. I know that my name is very long and hard to spell, so you can universally find me online by looking for the angry little dog in the box of beer. That is my actual dog, and she is exactly as mad as she looks in that picture. So to get started, I'd like to start with a conceit, which is that understanding data is hard. Who here, as a developer, works with data kind of in their day-to-day life? Yeah, pretty much like everybody, right? And so you know that looking at very large data sets is extremely difficult. So this is actually even more compounded, right, when we look at geodata, or data that has some representation in the real world, because of this context that we call the world, right? When we look at things like latitude and longitude points, we have some ability to process that intuitively as human beings, but to actually insert that into the real-world context that it exists in is essentially impossible. So to illustrate that, this is a gigantic array of different latitude and longitude points. Anybody want to guess what these points represent? Some shape. Anyone else? Guesses? What is it? Location? Location of what? Location on the map, yeah. Other guesses? Coordinates, right? So yes, it is coordinates, but you're all a little bit right. In reality, this is absolute garbage, and it represents absolutely nothing. I generated all these points by smashing my hands on the keyboard over and over until I got a bunch of completely arbitrary latitude and longitude points. My point being that this could represent anything to us, right? We have no ability to understand this data in the real world, even if I didn't actually just randomly generate this, right? So, the question then is, how can we understand geodata? Because the pin has served us really good for a really long time, right? Don't get me wrong. I work on the Maps team. We love the pin. The pin has done all kinds of things for us over the years, but when we're talking about extremely large data sets, or we're talking about trying to visualize aggregated geographic data, it falls rather short. So this is where Deckgl comes in. So Deckgl is a WebGL-powered data visualization framework. What does that mean? That means that Deckgl utilizes the WebGL library in order to process very large data sets and then visualize them in 2 and 3 dimensions on top of the map. Primarily, Deckgl was built for a mapping use case. That is not to say that is the only thing that you can use it for. It's just that is what it was primarily built for. Some other details, it takes a layer-based approach to visualization rendering. I'll explain a little bit more about that in a minute. And kind of importantly, it comes with a whole bunch of really beautiful visualizations right out of the box, which saves us a lot of work. But wait, there's more. Also, built from the ground up to support extremely, really large data sets. One more time, who here has worked with the Maps API before on the web? Any of you ever tried to put more than 300 pins on the map? doesn't work out super well. The truth is that our markers tend to start to have some performance limitations when you get to putting several hundred markers on the map. Now, Deck.gl, because it pushes the render off to the GPU using WebGL, supports extremely large data sets. Last time that I checked, the most points that were rendered on a Google map with Deck.gl was something like 6 million. So when I say large, I'm talking about extremely large. Also, Deck.gl provides us with a number of niceties right out of the box, including automatic handling of things like animations, resizing of points. Some of these are things that you might not actually normally really even think about. But for example, right, if you're talking about 6 million points on the map, it turns out that as the user zooms in and out, right, you probably want scale of those points to automatically adjust, because part of any data visualization, geo or otherwise, is about presentation. Also, Deck.gl allows you to build custom layers if the ones that you get out of the box are not to your liking. You can either build these from scratch because the framework exposes its underlying WebGL context to you, or you can subclass any number of layers. In fact, pretty much every layer in Deck.gl is subclassed from an original base layer class. And really importantly, initial support in the Google Maps JavaScript API is now available. We just announced this at I/O this year. If you're interested in sort of the guts of how the Deck.gl team got the framework working with Google Maps, and you enjoy reading about issues like camera syncing, then later on I'll have a link that you can take a look at that goes into all the details about that. But even more importantly than that, it's awesome. And this is what's really important. So this particular visualization that you're seeing right now, the dots, not the kitty behind the kitty, is what's called a scatterplot layer. And all it is just a whole bunch of dots on the map. And this is a rendering from an open data set from the city of Paris that shows all of the trees in the city and has the latitude and longitude points for all of them. So each different color represents a different tree type. And aside from just like looking really great, an interesting thing about geodata, right, is that when you take this data and you put it in its real-world context, it tells you more about the data than just like where it's located, right? It tells you kind of a story about a place. In this case, you can actually visualize, how a city was planned out in a lot of ways. You can, in different data sets, can tell you all kinds of different things about a place. So how does it work? How many JavaScript engineers or JavaScript developers in the room? About half? No, there's got to be more than that. How many JavaScript developers in the room? Raise your hand. Cool. So then you're going to love this, because every JavaScript developer, when you ask how does the framework work, has the same answer, which is, who cares? It's awesome. One of the great things about Deck.gl, and really any framework, is that it abstracts away a lot of the complexities of implementation from us. So again, you get all of these things from Maps and from Deck.gl directly out of the box, without having to do a whole bunch of work yourself. I mean, don't get me wrong. Like I said, it does support building of custom layers if what comes with it doesn't do what you want. But like, I don't want to write a bunch of vertices and shaders. I don't know about you. So that is a really great thing about having this available to us. But let's just give a quick short version of how this really works. So Deck.gl utilizes the HTML canvas element. This is its rendering context, where it actually inserts the WebGL context in order to render our data visualizations. In order to put that on top of the map, it takes advantage of a API that we have in the Maps JavaScript API that's called Overlay View. One way to think about Overlay View, and you can use this, many people use this for their own purposes to draw on top of the map, is imagine that it puts a transparent layer on top of the map that is a full context that you can manipulate, and that is automatically synced with the map as the user does things such as panning and zooming, right? And then last of all, Deckgl adopts a reactive programming model for performance reasons. And later on, when I show some animation stuff, I'll get a little bit more into how that works. Before I get going and do some actual demos, these are links that you can use. This first one is a demo running live that you can play with right now. Maybe if everybody in the room played with it all at once, it might brick my App Engine instance, so maybe check it out later on. And then the source for that demo, as well as separate code bases for individual layer types, is at the second link below. For anyone who is familiar with Google links, I would like to point out that these are GU.gle links, not GU.gl, which is what you might be familiar with from many years past. Took about 10 years of research and development, but we did manage to get the E. So enjoy that. All right, cool. Let's look at some actual demos of how it works. So I'm going to look at a couple different things today. This is just a really basic demo of a few different layer types, and I'll just walk you through how this works. The things that you really have to care about in this case are, we have an index.html file, pretty straightforward. Everybody can parse this pretty easily. Have a little bit of styling for the map. That makes it full screen. We have our map div. This is where the JS API is going to actually inject the map for us and load it. And then we have a script tag that's just pulling in app.js. Pretty straightforward, yeah? Next, we have our app.js. And here we are importing a few different things. The first one, Google Maps overlay. So this is a class from Deck.gl that is the class that actually instantiates the WebGL instance and puts it into our overlay view. Next, we have a couple different out-of-the-box layer types from Deck.gl. So first, I'll show you the scatterplot layer, and then the arc layer, and then the third import is just styles. So a lot of people actually aren't aware that when you use the Maps JavaScript API or any of our mobile SDKs, you can pretty much style anything that you want about the map. Actually, a really good example of that is on the website for this DevFest. They've done a really nice job of styling the map so that it fits with kind of the overall theme of the site. But we have some cool tools for that as well, like we have mapstyle.withgoogle.com. Let me reload this. And here, you can, for example, start with a bunch of different neat base styles, and you can pretty much customize just about anything that you want about the map. Everything from the colors of roads and different geographic features to the resolution of labels, just about everything. In fact, you can make the map completely blank if you want. Cool. So next, I have a couple data sources. So these data sources are just open data APIs that are available, in this case, from the city of Chicago and the city of New York. We'll see how this goes, because one of the issues with giving a demonstration of large data set rendering is that sometimes it bricks the conference Wi-Fi. So let's see how that works out. The next things that we want to look at, this is just a basic script that is going to load the map. You can see I pull in my API key, the normal URL that's used to load the Maps API. Anyone who's used the Maps.js API before is probably more familiar with the whole script tag include. But in this case, we're loading the script, we're loading the API dynamically in our app.js file because we need to know that it's loaded before we load Deck.gl, because otherwise there's nothing for the Deck.gl overlays to attach to. So that's what's happening here. We're just resolving a promise once the Maps.js API loads. And then here, we're initializing the actual map. So depending on which demo I'm running, I define a different center point. This is where the map is going to load as its center point once it comes in, different zoom level, so I can specify that. Then I await for the map script to load. And then this is where I actually instantiate the map. Pretty straightforward, everybody. Any questions? Cool. So, next part. So I'm initializing the map. And then I'm creating the overlay. So the first thing that I need to do is instantiate an instance of Google Maps overlay. Again, right, this is what injects the WebGL context into the overlay view. And then that overlay can take a number of different properties to define what it should do. The one that we really care about is layers. So layers takes in an array where we just pass in different instances of various Deck.gl layers. Right? This is important to note that it's an array. For the purposes of today, I'm going to keep it simple and just do a single layer at a time. But you can do something like up to 36 or 37 different layers at once on top of the map, which is really important for things like creating composited data visualizations. So for example, if I'm pulling data from multiple sources and I want to show them all on the map at once, right, I can overlay them all in aggregate. This is also a strategy for performance as well, because as you can imagine, if I'm pulling in like 1 million data points over HTTP, guess what? Like, that's pretty slow. So what you can do is there's different strategies. For example, chunking your fetches in order to make the visualization perform better. So in this case, I'm passing it a scatter plot layer. Every layer in Deckgl has a different ID. This is how Deckgl actually makes, in the case of how it's implemented in Google Maps, this is how it makes the reactive programming model possible, is that it's able to identify recursive, or it's able to identify successive renders of the same layer by its ID and then do shallow diffs in order to only re-render the pieces that need to be re-rendered. Then all of the layers take a data property. So in this case, I'm passing it the URL that I showed you above. Now, this is another really nice thing about Deckgl. It actually supports a whole bunch of different ways of importing the data. So for example, if I brick the Wi-Fi, I'll pull it in from a local file. And we can see how that works. But I can pull it in from like a local JSON file. I can pass it a promise if I want. In this case, I'm giving it a URL. It identifies that it's a URL, and it just implements the fetch for me, and then resolves the promise on its own. That's pretty nice. It's a lot of stuff that I don't have to worry about. And then we have a whole bunch of various properties that define the look of the visualization. So in this case, this is a scatter plot layer, so it's the opacity of the points, whether or not they're stroked, whether or not they're filled, what color that fill is, and then these like radius min pixels, radius max pixels settings define things like what happens right to the scaling of the points as I zoom in and out. Last couple things. So this get position, every layer has some sort of property that tells it, okay, when the data is pulled in, this is where you're going to look for the latitude and longitude pairs that define each data point. So in this case, right, I can give it a function. This function is going to iterate through the data one row at a time. And then it's going to look, in this case, it's going to look for it within the object, the geom, and then coordinates. Make sense? Cool. And then we can also define the fill color and the line color. We can even do this dynamically if we want. So for example, in the visualization that you saw of trees in Paris, right? Within these properties, I could say, if the tree is of type X, then make the color Y, right? And then lastly, I call overlay.setMap. And all this is doing is it's taking this Google Maps overlay, and it's telling it what instance of the map I want to pin it to. Oops. Let's run it. So just a simple Webpack dev server, and then it loads up my map. Hey, that's pretty good. That's pretty good Wi-Fi. So this is 70,000 street trees in the city of Manhattan. And the really cool thing about it, right, is it's not just the visualization of each data point, right? It's the performance. So we can look all the way down to the street level, right, and view sort of like the distribution of this data. But again, in aggregate, it tells us a little bit something about a place, right? Like in Manhattan, we have this big empty spot in the middle where there's no street trees. What do you think that is? It's Times Square. Not a lot of trees growing in Times Square, it turns out, unfortunately. So that's pretty cool, but let's look at a different one. So I'm going to save you all the pain of watching me live code and debug this, and I'm going to use the miracle of copy and paste. Oops. Cool. So I'm going to just change my visualization. I'm going to center it on Chicago. And oops, this is a different layer, a different default layer. It's called arc layer. What arc layer is meant to do is to show the connection between destination and origin points. So if you can imagine, for example, all of the flights leaving an airport and showing arcs where they end up connecting to. In this case, I'm pulling in an open data set from the city of Chicago that shows taxi trips between different neighborhood centroids. So taxi trips that originated from one neighborhood and ended in another. Again, unique ID. I have the data. And then dynamically, I'm telling it where to get the source and the target positions. Incidentally, pretty much all of the layers also support this data transform property, which is a property where you can insert a function to kind of pre-process the data. So for example, if you wanted to do some other massaging of the data before to kind of uncomplicate these properties, you could do that. So we save that, watch it reload. And this is what we get. So this is 65,000 or so taxi rides within the Chicago area, which is pretty neat, but it kind of looks like a big blob, right? But what's really cool is when you do this. This is actually the highest resolution screen I've ever done this on, so this is a little exciting. But what you can see there, right, is this is 67 or so thousand arcs individually rendered in three-dimensional space using WebGL. And so we get really immense performance out of it. And again, we can go all the way down to the ground, right, and see how these perform. In this case, also, I forgot to note that the coloration that you're seeing, right, is you can specify a source and a target color, and this is just to help you differentiate when an arc is leaving a place versus arriving. So it handles the color, the styling and the gradient of that for you automatically. Not bad. So I have just about like 10 minutes left, so let me do one more. I had mentioned before that Deck.gl also handles some things for us, such as animations out of the box. So let's take a look at a different one that's called trips layer. So here, same thing, I'm just importing the layer. In this case, it's coming from the geolayers module in Deck.gl. And I'll just run through this code really quick. So essentially, what I'm doing in this particular one is I'm using our Places API. I'm generating 10 different restaurants around the center point of the map. And then I'm using our Directions API in order to generate directions that connect each point to each other. So in total, I get about 190 different trips out of the data, all right? So here is where I'm retrieving that place data. The location is just the center of the map within a radius of 3,000 meters, and I'm pulling back restaurants. So with the places API, with each fetch, I can pull back 10 places in one go. Then then what I'm doing is I'm using the nearby search feature in order to query that set of points. Once I have those, long story short, I am just iterating through them and then calling the directions API, right, in order to get directions between every 2 points. Again, for a total of 190 or so different trips. And then I have this little node server running that's just orchestrating the calls to the directions API on the server side for me, just to kind of keep things simple. Again, I'm loading the map, and then initializing the map on top of New York City. Now the difference comes here. So when I actually run the program, right? So I load the script, I initialize the map, I do all my stuff to get my places and generate my directions so that I have my set of 190 trips. But you'll notice this time I'm instantiating Google Maps overlay and setting the map for it with nothing inside, right? So when it first loads, completely empty overlay on top of the map. Then what I'm doing is I'm calling render. So in the render function, I am calling the Google Maps overlay member function set props. So this is how you can continuously re-render a specific layer over and over. So in this case, right, this is that same layers array from before, and I'm passing it a trips layer. Now, everything's pretty straightforward. I'm giving it the data, which has my different trips in it. This is where all of the different segments that make up all of the turn by turn of the trip is in the object that's returned. I have various styling. But then the main difference, right, is I have this current time property. So what this current time property tells Deck.gl is within the context of the total time span that this animation is running on this specific render the position at the corresponding timestamp. And with each recurring render of the layer, I'm incrementing current time by 1. So you see what's happening there is I'm just loading the exact same data over and over, but I'm telling Deck.gl to move forward in time, basically 1 second per each render. And then I call that, and then I just call this render function recursively using request animation frame. So the cool thing about this is that not only does Deckgl handle the animation and the rendering of the layer for me, it also, because I'm calling it with request animation frame and it's this trips layer, it's actually doing the in-betweens for me as well. So for every single frame of the animation that I ask for, it's actually also doing a render of about 3 to 4 in-between frames as well, so that I get a nice smooth 60 frames per second animation. So let's see how it runs. May take just a second for the data to load up in this case. So we're back in Manhattan. There we go. So again, right, like under the covers, it's great that all kinds of complicated things are happening, but what's even better is I don't have to worry about figuring out how to do these animations myself. I just get this visualization out of the box. And again, you can go all the way down. Oops, I missed it that time. And just to show you something kind of cool, like let's change the color up and maybe the length of the individual trails and reload again. Give it a second to go. Yeah. And you can see how just changing the styling of the visualization, right, kind of changes your whole perception of the data and what it represents. This one's very like Tron-esque, which I'm pretty into. Cool. So again, if you want to go to this URL at the top, you can find demos of all these various things running. Actually, I have a couple more minutes, so let me show you one more. I won't go through the process of showing. I'll just show you how it runs. So another way that we often want to look at geodata, right, is in aggregate. So you can imagine hexagon layer as sort of a bar chart on top of the map. So this is loading 120,000 different active businesses inside of the city of Los Angeles. So 120,000 is going to take a second, especially on Wi-Fi. Maybe while we wait for that, I will go back. Congratulations, everybody. I think I did brick the conference Wi-Fi. Real quick, while we're waiting on that, I'll go back to this. So you can get the source at the bottom if you want to try it out for yourself. Also, we have really excellent docs for the Maps platform. This link will take you to the top of the docs where you can explore across all the different APIs and SDKs. And then the second link goes specifically to the docs in the Deck.gl doc set that talks about Google Maps overlay. And then the bottom link is for that blog post that I told you about where it really gets into the guts of how this integration happened. Let's see if it loaded in the meantime. No. Oh, API broke. Alas. Cool. In any case, thanks a lot. Again, that's my Twitter handle on the bottom, so feel free to, if you have any questions, reach out at any time.
Thank you, Alex, for your talk. Do we have any questions? Yes, we do. OK. Can you make the points on the map clickable, for example, to display some details about a point?
Yeah, absolutely. I just didn't show that property. But there is a particular property that's called, it's not called clickable. In any case, there's a standard property that makes it so that it triggers like an event handler inside of Deck.gl. So you can do like on hover events, on click, all that good stuff.
Perfect. And the next one, is it possible to run Deckgl in Flutter app or any native mobile app, or is it possible to run it only in web apps? So
Deckgl relies on WebGL. So it has to be in some sort of browser context because you need a WebGL context in order for it to go. Now that being said, right, you could put a web view inside of a native app, for example.
Thank you. And there's another one. Does it provide points aggregation?
Yeah, if only that last demo hadn't failed.
Can we switch to, yeah, thank you.
Let me see if we can actually get that one running. Yeah. No, 120,000 data points, too big for this Wi-Fi, apparently. But yes, it does provide data aggregation. So for example, in this hexagon layer, what it does is I give it this big spread of lat longs for it to load, and then I give it geographical buckets, and then it aggregates within those areas, and then visualizes the relative concentration of data points as three-dimensional bars on top of the map. Let's see what happens. Cool.
OK, can we get the questions again? Thank you.
I'll let you know if it loads, and then we can come back to it.
Yeah, we saw that. How do the click handlers affect the performance?
Well, you're not going to want to implement like clickable points if you have 1 million things on the map, right? But also, that's not really going to make sense to do. If you have a million points on the map and you do some sort of like on hover event, you're going to be triggering that event an awful lot of times. So I guess the short answer is it performs great within the context where you would want to use it.
Perfect. Any other questions? Nope. So thank you very much.
One more.
Sorry? Yeah?
When you had these animations of cars, was it in data or data providing just start point and end point, and this was computed like Google Maps style?
Yeah, so the way that particular visualization works is you give it an array of different lat long points, and then each point has a timestamp on it. And so so what Deckgl does is it within the timestamp range between 2 points, it animates between those lat longs. So for example, if you wanted to represent curvatures, oh, cool, it loaded. Sweet, can we put that up? Yeah. So like if you wanted to represent curvatures, right, you would need like a lot of points or more points so that it looked curvy. So this is, yeah, an aggregation of data. This is pretty neat. So this is active businesses. And again, right, like completely rendered in 3 dimensions. But the more important thing is that you can tell something about a place. So for example, this concentration here of businesses, that's downtown Los Angeles. My favorite one is you come up here and you see this long strip, right? That's Ventura Boulevard. So again, right, you learn something about a place by being able to visualize the data in this way. Cool.
Okay, any other questions? No? So thank you, Alex,
Awesome.
for a speech.